Hello Trig, this is your first lesson by video experience. So generally speaking, when we get to chapter 8, we do 8.1 and 8.2 in one day worth of lesson. And I usually do 1 day worth of homework off of that covers 2 pages. Just I'm going to have some sympathy on you because of the difficulty of distance learning makes everything, I think, more complicated. So we're going to do still the same double lesson, but it'll do 2 days worth of homework instead of 1. So compared to the syllabus, we'll split the pages up into 2 different days worth, but I'll still run through this all in one big seminar here, 8.1 and 8.2. So I'm in the book, I'm looking at page 236. I believe you had a page of notes in your packet that went with this that was probably the very last thing you had in there, but if you didn't, you can do it without the notes sheet because I threw the notes on the board anyway, and it's mostly just reading. So on 236, it says, Introduction to Probability. This chapter is about probability. They say, you have used statements such as, I shall probably be home by 10 o'clock, whenever you're fibbing to your parents, conceivably. Mathematicians attempt to make the word probably have a more precise meaning by attaching numbers to it. For example, the probability of rain may be 30%. Today, in fact, I think the probability of rain is 100% because it's quite rainy today. The idea for doing this arose from the analysis of gambling games several hundred years ago. So there's a lot of dice card questions in this chapter because that's sort of how this got born, was through a lot of gaming. They say, suppose that 2 dice are rolled, a black and a white one, so you can tell them apart. The possible outcomes are shown in the figure 8.1a, which is at the bottom of the book on 236. And I believe I ran that off and included one of those in your packet in a slightly larger form. There's 36 possible ways in this chart that events could come up. You could have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Or if you have 2 on the white, you could have 2, 1, 2, 2, and so on and so forth. There's 36 different pairings. They say since each outcome is equal, or I skipped the reading there, there's 5 ways the total on the dice could equal 6. You could get a 1, 5, a 2, 4, a 3, 3, a 4, 2, or a 5, 1. If you're trying to roll a 6, I'll get to that chart in a minute, there's 5 ways you could do it. Since each outcome is equally likely, you'd expect that in many rolls of the dice, the total would be 6, 5 times that we counted right here. Out of 36, that's the total amount of possibles from the bottom. This number, 5 over 36, is called the probability of rolling a total of 6. Here's a helpful tool that's not in your book. If you were here, I would ask you, what's the lowest possible total you could roll with 2 die? 2 dice. Die is 1, dice is 2. So I could do this like Dora style. What's the lowest total you could roll on 2 dice? That's right, class. It would be a 2. How many ways are there that you could roll a 2? That's right, only 1 way. There's only 1 way on that chart that you can have a 2, which is the very top left corner choice. If you had a 1 and a 1 in that top left corner, that gets you a 2. There is no other way that you could roll a 2. That's it. Could you roll a 3? Sure you could. 4, 5, 6. If you were here in person, I'd ask you, what's the highest total you could get? I'm not going to do that Dora style because Dora is tremendously annoying. Sorry if there's Dora fans out there. Creators of Dora, if you see this, please don't sue me. But the highest you could go is up to 12. 12 is the highest total you could roll on a pair of dice, 6 and 6. That's it. It's the highest you could go. So a moment ago, they told you that if you rolled a 5 for a 6, what did they do a minute ago? They said that for a 6, there were 5 options, and we counted those off. If we were here in class, we would count these off together. I'd ask you, how could you roll a 3? You'd have to think that through. You could do a 1 and a 2, or you could do a 2 and a 1. There's 2 options for doing that. You can imagine this is the white and this is the black, I suppose. So to get a 4, you could go 1, 3, 2, 2, 3, 1. That's it. 3 options. And you probably see a pattern emerging here. 5 has 4 choices. 1, 4, 2, 3, 3, 2, 4, 1, 4 ways to do it. 5 for this. This has 6. To roll a 7, you could go 1 with 6, 2 with 5, 3 with 4, 4 with 3, 5 with 2, 6 with 1. And then if someone were here in class, I'm sure I could bait somebody into yelling 7, and I'd say disagree. There's going to be 5 ways to get an 8. Don't get too carried away with yourself as you're counting up, because if you think about how many ways are there to roll a 12, that's not very likely if you play too many dice games that you're rolling 12s. There's only one way to get a 12, which is 6 and 6. This has to come back down. There's a symmetry to this. The beginning and end are the same. And as we march inward, the numbers should match marching inward. This had 2 options. So does this. This has 3. This has 4. This has 5. If you don't believe me that this has 5, let's play the hands game to get totals of 8. We could go 2. Can't roll 1 here because you don't have 7. So we could go 2, 6. We could go 3 with 5, 4 with 4, 5 with 3, 6 with 2. There's 5 ways you could roll an 8. And if you add that all up, the grand total we already mentioned earlier was 36. So what the homework is going to do is tell you some little stories about situations rolling dice. Anytime they use the word total in the story, you're going to use this chart. So a lot of these are saying total. I guess I should have said the word total there as well. Anytime they use the word total in the stories, we're going to think about this chart we created. If they don't use the word total, you'll have to look at the chart they created that's in the book that I Xeroxed for you. So everything's going to be a fraction on top of 36. So we'll just get that out of the way right now. There's 36 possible options on the chart in the book for things that could be turning out. So every answer has to start off on 36. If I ask you for a total of 7, we already answered that question. Total of 7, there were 6 ways to do that. This is 6 over 36. Invariably, someone will ask, should we reduce? And the answer to that is always. We want to get down to 1/6 by reducing. If the total is over a 10, the total being over a 10 means it could be an 11 or a 12. That's what's above 10. So if we're thinking 11s and 12s, go get their counts. There were 2 of these. There were 1 of those. Put them together by adding. There would be 3 ways to get above a 10. Reducing would be 1/12. If the total goes between 3 and 7, that means it's either a 4, a 5, or a 6. If we're between 3 and 7, 4, 5, 6 are the numbers that do that. So the 4, 5, 6 zones generate these numbers. 3, 4, and 5 added up is 12. So 12 over 36 is 1/3. If I say between 3 and 7 inclusive, if you were here, I would ask, what do you think that means to be between 3 and 7 inclusive, as opposed to between 3 and 7? This meant 4, 5, 6. So Dora style without the blinking. What does this mean? Think about it. That would mean it's 3, 4, 5, 6, or 7. The word inclusive means it's all the stuff between them as before, but 3 and 7 themselves get included in the list. So if we work from 3 to 7 inclusive, it's all 5 of these levels between my hands. Stepping over here to grab the 5 numbers that we can see and add them all up, and that would add up to 20. I like to add up by grouping things into tens. So 6 and 4 are first on my mind is a 10. 5, 3, and 2, that's another 10. But 20 out of 36 can reduce by 4s down to 5/9. If we do a total at least 9 means that 9 counts and we go up from there. So 9 or higher. We'll take a step and see what this is. Maybe we'll receive this call, or maybe we'll call them back. We'll call that one back. That's just Mr. B. So total at least 9, we go 9 and up. So all of these numbers from 9 and up, 4, 3, 2, 1, that adds up to 10. Reduce that would be 5/18. I then stopped using the word total, so I'm not going to use this anymore. We'll step over there. I'm not sure what happened to me, but I suffered my first video filming injury. Somehow these problems drew blood. I don't know what I did that could have drawn blood, but something got me during this lesson. I know your heartfelt sympathy right now is going out to me over this tragic event. Very strange. I think I'll survive. For this one, we have the numbers being 2 and 3. So we're going to look at the chart. If the numbers have to be 2 and 3, look through your chart and think, are there pairings where the numbers are 2 and 3? And the answer is yes. There are 2 such pairings. There's a 2, 3, white, black, and there is a 3, 2, white, black, the pairing. That can reduce to 1/18. If I ask you to find a pairing on that chart where they have the dice doubles, if you look for a grouping where the black's 2 and the white is 3, if you look around, can you find that? Yes. Can you find it a bunch of times? No. There's only one pairing on that whole group where the black's a 2 and the white is a 3. And is a tough word. And means you need all of it to happen. Like if your parents go away for a weekend and they say, I want you to clean the garage and clean the room and clean the attic and clean the basement and do your homework and make all your meals and wash the clothes. Like the only way you have happy parents is you did all of that stuff. That's not easy to do. The word or is a lot softer. If they did the same thing and said the word or every time, you just could do one of those things and you'd be good. So if you look around on this chart for the black being a 2 or the white being a 3, that's going to be a lot more choices on that because it's easier to do it. So if you go looking for black 2s would be a full column of 6 going this way. There's 6 of them that have black 2s. If you look for ones that can have white 3s, there's a line this way of 6 of them that have white 3s. And if we're here in person, there's usually about a 5-minute logjam where people argue with me that made 12 choices and it does not. If you want to solve that mystery, pause the video and solve it. It might take you a couple minutes. But there are 6 this way. There are 6 this way. That does not make 12 of them. If you don't get it, pause it, think about that as long as you want, and get the answer from me when you unpause. As soon as we're back, I'll do that. So go ahead, if you want to figure out why it's not 12 on your own, try it and pause. And when we come back, the issue is that when you do 6 this way, and you do 6 this way, there's one right here where my arms are clapping together that got counted in both groups, but there's actually only 11. We have 1, 2, 3, 4, 5, 6 that way, but then there's only 1, 2, 3, 4, 5 new ones this way, because you have one that's in both groups that you don't want to double count it. So when you count 6 across, you already got this one. When you count 6 this way, don't count it again, you already counted it. Okay, so there's 6 one way, there's 5 new ones the other way. That's 11 out of 36. Page 237, you could now do the 1 to 13. But while we're at it, 8.2, there are some words associated with probability. So I'll just sort of read this through with you while chemistry papers go flying. It says, so that people may talk more efficiently about probability, various things are assigned names with precise meanings. For example, in the thing we just got done doing, the act of rolling the dice is called a random experiment. The word random means there's no way to know beforehand just how any one of those rolls is going to turn out. By the way, if you're here live in person, that would have just sent you from lunch to whatever you have after lunch. That's the time of day we are at present right now in the real world, in the making of this video here in our studio. Anyway, random experiment is just the act of rolling the dice. when we take tests, even when I don't suggest this word, every year somebody will put the thing random experience, and that's not it. Some days I tell them not to put random experience, and they still do. And then other years I won't even mention that, because I think sometimes by saying it, I made them say it, and they'll still come up with that somehow on their own, even if I don't say it. But don't say random experience, say random experiment. Any way the dice can come up is called an outcome. So on this chart, you have 36 outcomes. Outcomes are equally likely results of a random experiment. So every one of these 36 items on the chart was an outcome. An event is a set of outcomes. That's what I did when I told you a story. I told you about an event. And when I tell you about an event, and it makes you look at this, you might find a bunch of outcomes. So when I told you about the black 2 or a white 3, that's one event. That one event led you to 11 outcomes. When I talked about the numbers being 2 and 3, that's one event. It led you to 2 outcomes. The set of all possible outcomes is the sample space. The sample space is the name of this, where it's just everything possible. And then they define the probability more precisely in this definition category on page 237. The probability is the number of outcomes in an event to go on top, and the number of possible outcomes in the sample space to go on the bottom. And they're going to use punctuation like I did, that's kind of like the f of x thing with the parentheses. The p means probability, and then in parentheses I put some kind of a description of an event. And then the thing in the blue box I don't think matters. The note matters. All probabilities are numbers between 0 and 1 is a good thing to know. So if I asked you on a story like this, what's the probability you rolled a 27? It's a 0. That's impossible. Never just say the word impossible. Say probability 0. If I asked you something that was a guarantee, like what's the probability you rolled somewhere from 2 to 12 inclusive? Well, that's a 1. Anything guaranteed is a probability 1. I think that's it. So based on that, they're looking for you to do a 238, 1 and 2, which is deceptive because they both, one goes to J and one goes to K. But instead of using a sample space that's the dice chart you already have, they kind of want you to think through your own sample space about flipping coins, heads and tails, or they have a thing here with a deck of cards. So give that a shot. As always, if you have questions, email me and I'll answer them one way or another.